Okay, we'll go straight to the lectures. Okay, this week. Why is my slide not able to open? Okay, we will have a total of 3 sessions just on assembly language. Okay, so it's something that I hope that you guys can master, because it's a very important skill set. Okay, if you can master assembly language, you can do a lot of things. So take this opportunity in the lab to actually just you know, make sure that you know what you're doing, and not just copying. So if you're able to do that, then that will be actually great. Okay. Okay, can you see my slide? I think I seem to have to ask this question every single lecture, because there's no indication whether you can see my slide or not. So can you see my slide? Okay. Okay, good. Okay, so there's a total of three lectures on the assembly language. I think last week we've covered a bit about the assembly language in general, on how we perform interrupt and all these kind of things. So these 3-week lectures on assembly language, I hope that you guys can do a bit of revision, and I consider you competent if you can understand the instruction sets on your lab. All right, so if you can understand exactly each of the line, I think you're fairly competent in assembly language, because assembly language is about 27 instruction sets. It's impossible to learn everything in one semester, that I understand. So but at least you know the stuff, that reoccurring instruction sets that keep on coming out, like for example, in the LEDs, I shared yesterday in the tutorial, in the LEDs, bit set and bit clear, bit tests are the ones that actually keep on recurring. I sent in the document, PDF document, for you guys to just refer. There's a couple of common instruction sets. I'd like you to have a look, because the assessment for the final can just question you about the coding. Probably on the theory part, you guys are good with quizzes. You guys can do some revision. I think that's pretty okay. But when it comes to coding, you cannot be memorizing and mugging up the codes. So I hope that you guys can understand C and assembly. Both C is actually quite easy, because it's straightforward. Okay, nothing complicated. When it comes to assembly, it's something that is introduced to you in this semester. Okay, so we will start. Okay. Okay, this week we talk about further talk about the instructions. I think if you can recall, there are 3 types of I think from the very beginning I mentioned there are 3 types of instruction sets. First group is what they call the data. Okay, that moves the data. The second group is mathematical. They are logical and arithmetic type of instruction sets. Subtract, addition, and all these kind of things. Each of these instruction set actually affects the flags differently, individually. Okay. Then you have this thing called constant generators. This is a bit technical. Constant generators are a technique which we apply, because some of these, let's say for example, at certain numbers reoccur in your program more frequently than others. Okay, the number 1, 2, 4, 8, and so on and so forth. These numbers occur more frequently. Okay, not all the constants are similar. Well, can you not use constant generators? Can you just use you put in a value in the registers and then you run it? Well, you can, but technically it's a bit slow. All right, so a better solution would be to use constant generators from the existing registers. Okay, you're able to do that. We're just going to cover briefly, tell you what you need to know about this constant generators, and probably I'll take the opportunity to share with you how is it done in actual code in the tutorials. And we have this multiplication. If you really look into the instruction sets, there is no multiplication. Okay, and this the fourth element is basically specific to MSP products. Okay, so this is a more like a like a marketing thing. I'm not a sales engineer for MSP, but this thing is specifically for MSP products, Texas Instruments. Okay, they develop a way for you guys to do multiplication. Okay, so make it very easy. You have functions in assembly, so make life very easy for you. But the original multiplication is not in the original 27 instruction sets. So there are 27 instruction sets to deal with move, jump not zero, jump if carry, etc., etc. Look into the tutorials that we shared last week. Not last week. Actually, it's supposed to be last week, but I shared yesterday. Okay, so look into that particular tutorial. You can find there's only a couple of instruction sets that keep on reoccurring. Okay, especially at your level, your lecture level is actually this is an introductory course. Okay, so you're not dealing with a lot of complexity. You're mostly dealing with stuff like LED switches and so on and so forth. So that's where your domain of your learning is, the boundaries. Okay, so most of the instruction sets are related to LEDs and switches, interrupt, and so on and so forth. You're not dealing with stuff like stepper motors and all these kind of things. That will come in embedded system engineering. Okay. 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 Hold on for a while. I think my computer is a bit problem. Okay. As a reminder, operand in instruction set must be written with appropriate addressing mode. So all these instruction sets, okay, they you have to write it in a format. You have your mnemonics, you have your operand, and you have your labels, etc., etc. Remember last week we shared only the mnemonics and the operands are actually compiled into the machine language. Okay, the hex symbols that you see in your memory, those are actually instruction sets. For instruction other than jump, the 7 modes used by the MSP are given in the next slide. Okay, so you have jumps, then you have 7 modes. Immediate, indirect, auto increment are not valid as destination operands. So you cannot use it as destination operands. I'm going to share more about the addressing modes. So mode is something that reoccurring in previous lectures. So I think I will probably take one tutorial to share about this addressing modes. Okay, so addressing mode is basically how you transfer information. Okay, you can transfer information using absolute value. Okay, you put it in a register. You can use the values in other registers and so on and so forth. So there are various ways of actually getting information from one register to another. Okay. Now these are the easiest way to actually identify. Just like when you're doing C programming, we're doing introductory course. There's a lot of definitions involved, but as you grow more and more competent in programming, you seem to care less about this, this classifications, names, terms, and so on and so forth. Just like how when you learn English, they always tell you that this is a verb, whatever adjective. When you're used to speaking in English for a couple of years, you forget about all these terms. What's a verb, what's a noun, nobody cares. You just tend to use it. Okay, so table 4.3 actually shows the type of addressing modes. Since we're in introductory course, it's better to do proper. We have an immediate mode. Okay, we have an immediate mode where the value itself is stored to the register. Let's say, for example, this one is hashtag 13. Okay, and then you have your destination is R5. So this value 13 will be stored to R5. Then you have your register mode. It is very common. Move, let's say, for example, move R7, R6. Okay, whatever content in the R7 will be moved to R6. Then you have your index. Index in direct mode, and you have your auto increment. This one has an auto increment function. It keeps on adding 1 to the contents, okay, the register. And this is index mode. Let's say, for example, whatever that you have is in this value register, and it will index by X. Let's say, for example, you have 5 here, so it will plus 5 to the 5 to the register values, and then you will just index it. Okay, so it's this one is very convenient if you're storing things in memories. If you're storing things and you're manipulating things in memory, this one will be very important. Again, all this information are in the book. We can cover this in tutorial so that you have a more in-depth understanding. Okay, check the chat room. Any chats that okay, so you have no problem. Okay, no problem. I will continue with the lectures. Right. So and you have a direct mode. Okay, where the X is the address. Okay, you just move X to the the register that you want it as the destination. Then you have your absolute mode where X is basically the address. I think yesterday I've shared the tutorial. You can look at the different move functions, which is immediate, which is a registry, which is direct, which is absolute. You can see that most of the delays, okay, you use immediate mode. Okay, there's a value. Today I shared in the tutorial. There's a value created for the delay, the value inserted for the delay, how long you want the delay, and that one, most of the codes actually use immediate mode. Okay. Okay, the MSP has 27 hardwired core instructions with each specific opcode machine language. Okay, assembly also supports 24 emulated instructions with mnemonics easier to remember. So they also have these emulated instructions. They are not hardwired, but they are actually emulated. Okay, so altogether you have from 27 plus 24. Okay, some are emulated. Okay, for example, to invert all bits in R4, invert R5 is easier to recognize than equivalent core instruction. So you can see that this is immediate mode. Okay, immediate, is it immediate? I think the previous slide. Okay, immediate mode. Okay, so whatever values, okay, goes into this R5. There is no penalty for use of emulated instructions. So emulated. These are the more basic ones, the fundamental instruction sets hardwired, okay, and you have 27 emulated instructions. If you're familiar with using this in the in your undergrad, then probably when you reach your working life, you're still working in similar products, then you'll be very efficient in getting whatever that you learn for your work life. Okay. But most of the time when you are working, you do not know your future company, what kind of brand they're going to use. And most of them, the 27 ones are the common assembly. 24 emulated is something probably a bit different in every brand. popular ones are Freescale. Okay, you know Freescale, mostly used for Freescale products, mostly used for military and the healthcare industry. So you're designing something like a medical device, you know. This will be very common for you. Okay, healthcare products and military products. Okay, so you use you might be required to program specifically in assembly language, because probably C is a bit be a bit laggy. Okay, and you want to fully optimize whatever that you have product, you know, fully optimize the programming cycles. Probably look into assembly language. Okay, again, different brands. 24 is depends on brand specific. 27 are common. Even you look at those days, they use this they used to have this Intel product chip, call it I forgot, 8086 or something like that. Okay, so those are the products that we used to study in assembly language during my time. Okay, now it's a bit different. You guys have various instruction set. In fact, I've been looking at maybe in Arduino probably have equivalent instruction sets, this 27, but you have to find the IDE that supports assembly language. Okay, a quick look on the core instruction sets. So these are the core 27 instruction set. Okay? As you can see, data transfer is one group of instruction sets. The top one, move, push, swap, add. Again, they transfer information from one source to another. Okay. Okay, they transfer information from one source to another, and then you have this arithmetic, you have logic. This normally we group it as one. Okay, and then you have from this line onwards, jump if zero, jump not zero, jump carry, jump not carry, jump negative, you know, and all this. From this line onwards, they are program flow. They do the job of your if else loop, your for loop, and etc. If and all this kind of you know instruction sets. So you need to rely on this, and this one normally depends on the last category. Normally depends on either labels or flags. All right. So you have label. You jump to where? All right. So normally it depends on your label and your flag. Okay. So flag is what do I mean by flag? Status register, you have carry flag, you have a negative flag, and you have your etc. etc. Those are what we call flags. All right. Wait. Okay, recording. Okay, so those are what we call flags, and this category of instruction set normally they make use of the flags and also the labels. Okay. And these are the emulated instruction sets. So these are the things that is not hardwired. It's not designed such that it recognizes the hex associated with the instruction set, but they are emulated. Okay. Let's say, for example, what do I mean by emulated? When you're learning, let's say, for example, a lot of students like to do deep learning or neural network. Those networks are basically emulated on zeros and one. Okay, so those are emulation. Means to say that to copy, but it's not really running on the hardware itself. Okay, let's say, for example, you have a video game, 1980s video game, Kong or Pong or whatever. Okay, so you use your PC to try to emulate the hardware that runs those programs. So that's what we call emulation. You copy the hardware itself, but you copy the hardware, but it itself is not hardwired to the embedded system. Okay, these are hardwired to the embedded system. Okay, so you have pop. Okay, so the original one is push and pull, if I'm not mistaken. So you push. Where is the pull? Okay, so this is the push. Let me check. Is pool here? No, I think pool is the hardwired instruction set. Okay, push and pull is a hardwired instruction set. Well, I learned something new. Pop is basically an emulated instruction set. I thought that it's hardwired. Nevertheless, you have 27 plus 24, right? So these are all emulated, okay? And the 27 ones are the hardwired ones, okay, where you have this mnemonics. The instruction set recognizes it as a valid mnemonic, okay? Whereas these are hardwired. No issue, okay. CPU accept jump and operand in instruction could be one of the following. Is the CPU register name. Okay, the operand means you have a mnemonic. Let's say move R5 R6. So the move is basically the instruction sets, or what they call mnemonics, and the R5 and R6 are what they call operand. Now, accept jump instruction set operand could be one of the following. Okay, so these are the operands. Source and destination, source and destination. This is what we mean by operands. So when a quiz come out regarding this, when you have a quiz, your final 5th quiz, okay, ask you, what are the criteria? What are the possible source, okay, of operands? A, CPU, integer, character, valid. Then you have something stupid. Okay, make sure you choose accept. Make sure you do not choose any of this. Okay, so questions can come out from this kind of things. Okay. Registers. It could be registers like what we said. It could be a register. Let's say, for example, the easiest is move R5, R6. So the operands are actually registers. They can also be PC, stack pointer, status register, etc., etc. Okay. So it can be integer constants, okay, like what we mentioned. There can be constants. So this is related to constant generators. Just now we mentioned why you need to generate a constant. You already have these numbers. You can put in any numbers. Why do you need to generate constants? So it's much more efficient if you generate constants in terms of processing cycle. In MSP, in a source program to be compiled, the operand is direct giving an address. Okay, so this value is usually given as a label. Okay, for jump. For jump, you realize that except for jump, everything has a source and destination, an operand. Okay, except for jump. Okay, you look at jump. Jump only look into the flags and the labels. Okay, so except for this jump related instruction sets, the rest always have an operand. Okay, so jump main loop. Okay, it's not main loop. It's called main loop. Probably a typo error. Now when you jump main loop, except for this instruction does not look into even the carry bit. Okay, the carry, the flags does not look. It's straight away you jump here. So basically, it does not. This instruction does not carry any operand or flags or condition. It just does whatever it's supposed to do, because it's improbable that a programmer knows the address before compiling. Okay, so this label makes it convenient for you to do not need to memorize the location of the instruction sets. Okay, so probably main loop is somewhere in the program. You just put in a label, it will do the automate it for you. You do not need to memorize. Okay. But the problem with jump is that let me give you a scenario. When you have a jump, you cannot jump too far. Okay, you can jump a few lines. You cannot jump too far. Let's say, for example, your instruction sets. You have a code of 40 pages. You cannot jump too far. You cannot jump from page 1 to page 40, because you're bound by the limits of plus and negative 512. So you can jump the address. You can jump back to the previous address 512, or you can jump ahead of address 512. So you're limited by the how far you can actually jump. Okay, so you cannot jump too far. Now, what happens if I want to jump far? Let's say, for example, I want to jump from page 1 to page 40, how would I actually do that? Okay, so you can have a nested jump. Okay, you jump from one place first, then you jump to another. You keep on jumping. You jump probably 4 or 5 times. This technique is what we call nested jump. Okay, you cannot jump too far using just one instruction set. Okay. Okay, now I think this one we've discussed word and byte. It's very common already. I think short quiz. Okay, by default, is it a .w or .b? Okay, any instruction, if it's not stated, let's say for example, it's not stated. Okay, it's not stated, and you just put there, move. If it's not stated, did not say whether it's .b or .w. By default, it is a .b. Means to say only the lower byte are affected. Now this one, make sure you guys know about this. Okay, move B R5 R6 means to say that only the lower byte is being in R6 is being replaced by whatever that's in R5. The higher byte is not affected. Again, I repeat, move .b R5 R6. Okay, the higher byte are not affected, only the lower byte. But if let's say is move .w R5 R6, need to say that the whole content, the whole word itself is being replaced. Okay, so this one is a trick. It can be a trick question. Be careful. Okay, so whether it's a .w or .b, it makes a lot of difference. By default, if you do not mention it, you just say move R5 R6 is a .b. Okay. When data is in the register, since 16-bit, the situation is different. Source operand only points to the least significant bit. So if it's a byte operation, you only affect the least significant bit. Okay, so this is an example. Byte operation with a register A. Okay, before, and then you have this. If let's say if this is a W, a .w, okay, you have this is a word operation. But if it's a byte operation, only the lower byte is affected. Again, I just like to repeat and repeat so that you get what I mean. Okay, move .b R5 R6. Okay, so only the lower byte, just like what is happening here, only the lower byte is affected. The higher byte not affected. Okay, so if the original R6 does not have any value initially, it said it will be 0, just like what we have here. Okay. Then we have this thing called constant generators. What I can tell you guys is that think of it this way. You know, you can move a value, just like the delay in tutorial yesterday I prepared. Section 5. Okay, section 5, you have a value, if I'm not mistaken, is 1832. Okay. Now this value, you put it in the register, you keep on decrement this value. Okay. Because it's a very weird number, it's a 1832. There is no such number in the register. There is 1, 2, 3, 4, and 1, 2, 4, 8. Okay, these are common numbers that you always use. Can you think about when you're very proficient in programming? Think about in which condition you normally use 2. It's a lot. Okay, so everything is in base 2. That's why 2, binary 2 is the most important number. All right, so you always create functions, you always create programs that keep on using this number 2. And if you keep on using immediate mode, okay, to get this number 2, you will waste a lot of programming cycles. And what you can do is you can extract this constants 2, 4, 1, 2, 4, 8 from the status registers. Okay, we're going to show how to do it, but for this lecture, just accept it at this level. Okay. These constants can be generated, and when they are generated, they're normally more computationally more efficient. Okay, so you can generate if you want 0, 1, 2, and -1, you can generate it from register 3. If you want 4, 8, and 0, you generate it from R2. R2 is basically the status register. Okay, the status register where you get the carry flag and this flag and that flag. Okay, So you can generate it. In terms of code, how you apply this, we will discuss this later. But in this lecture, enough for you to understand, it's more efficient to generate constants from registers rather than putting in a new value. Okay, so you have a delay. Okay, example, the delay program. Okay, the LED delay program. You keep on using certain values, but that particular delay, it's a very weird, it's a very specific constant. Sometimes you just like to change the value, so that's not practical. In other scenarios where you constantly use 480012, then it's better to use registers to generate constants. Okay. Okay, so these are some of the example of how you generate constants from R3, from R2. Okay, so these are good examples. If you can do both ways, you can do either this one, put this value into this value. This is what we did in the LED, the delay program. Okay, we put this value into R15. It could be 50,000, so on and so forth. Okay, but these are code generators. Again, you cannot generate every single constant. You can generate some common constants. 0, 1, 2, -1, 4, 8, 0. These are common constants that you can generate. This weird number cannot be generated. Okay, this is like a 50,000 or something like that, cannot be generated. Okay. All right. So assembly, interpret logic, and expression in operands. Operand follow rules. Okay. So these are normal. Even if you're doing normal maths, okay, the what's in the bracket comes first. Then the second precedence goes to multiplication and division. Then only you go for addition. So these are normal mathematical rules. Okay, if you have an equation or whatever, it follows. All right. So these are group one. Okay, plus, minus, negate. Okay, then you have multiplication and all these kind of things. Okay. Two instruction set absent from MSP instruction are those multiplication and division. So this one is a bit MSP product is a bit stupid. I don't know why. Probably because of the way it's designed. Okay, the design. You're not able to use two. Okay, group two. That is multiplication and division. You have modulo. You have addition, subtraction. You have every single thing, but you do not have these two instructions. Probably there's because of some trade-off, okay, and so MSP came out with a method for doing multiplication. They give you a function, okay, so you can use this. Is a valid type of multiplication. Probably they want it to be convenient. That's why they changed this particular multiplication function. Okay, so how it works is that you have your value, you put it into, you have different 4 registers. You have MPY, MPYS, okay, and you have your MAC, and you have your okay, you have 3. Okay, this particular 3 registers, you put the values in, okay, automatically the hardware will do the multiplication for you. Okay, so let's say, for example, you have A equals to A plus B multiplied by C, and you have something like this. Okay, so the MSC multiplication actually carries an operation of the type A plus B multiplied by C. Okay, so whatever that's existing in the A, okay, will be equals to A plus the B plus C. So you have to put, essentially, you have to put the values into these registers, MPY and MPYS, multiplication of unsigned 8-bit. Okay, this is for unsigned, and this is for signed. Okay, and this one is for accumulate function. So you have your accumulate. A equals to A plus B multiplied by C. So this is a cumulative function. MAC is the register that stores the accumulation. Where can we use this? Okay, so when you have a data logging system and you keep on wanting to accumulate the values, this is where it's suitable to use this. C could be a scale or whatever, and you know, you can extract the MAC from the registers. So this register contain the accumulated values. All right. Okay. So the answers, these are the MAC accumulates the whatever A equals to A plus B multiplied by C. So there's an accumulation. This is the part that is multiplicative, and this is the part that's accumulative. Okay. So MSP products in specific, they took out the multiplication and they replace it with this function. It's an assembly function, but only specific for this type of instruction set. Now, where is the answer for if you change the value every time you change a value into this MPY registers, you get the answers in two registers. The results in high and the results in low. If you combine it, you get the full answers. Okay. So again, the first operand you put it in the MPY. The second operand is in OP2. So these are the registers. You put this value here. Okay, it could be move some values into here, and then you move some values into here. Okay. After you change the value, the results of the multiplication will be resolution high, result low, result high. You combine it both, and the cumulative value you get it in the MSC. Right. So this is a very convenient way of doing. Probably there's a reason why they took it out, because probably they did a survey. Okay, I retract back. They're not stupid. Probably they did a survey and they found that a lot of people prefer this method better. Right. Okay, so load first the operation in MPY is not and the first value that you want to multiply. Let's say, for example, it's A equals to plus B multiplied by C. So the first operand is B, second operand is C. So you move the value just like how you move immediate value. Immediate value move, let's say 5 with the hashtag 5 to MPY. Okay, to the address of MPY. Okay, then you move the second value to the address of OP2. Okay, after the value change, you will get the results, the high result and the low result. High byte, high word, low word. Okay, so multiplication, it's a very long instruction, because the multiplication operands are 8-bit. Okay, so 8-bit you multiply, it becomes very big. Okay. Load the first operand, okay, in either of these, MPY, MPY sign, or MSC. If you want to be accumulative, if you do not want to be accumulative, it's okay. You just load it in MPY. Then the second operand in OP2, okay, and the results will be available in the results low, result high. So you combine. You need to do some programming to combine. Okay, to get the result in either the high byte or the low byte. Right. So this is an example. Okay, you move this value A into here, move it into B, and you delay to settle. Okay, so standard procedure. Basically, it's a small delay for you to wait until the answers are generated. Okay, so just a small delay will do. You don't need to count 50,000 times or whatever. A small delay will do. Okay, and you restore the interrupt. Okay, you disable the interrupt first, then only you do the multiplication. So this is a common procedure. Look into this. Okay, common procedure. You disable interrupt because you do not want any of the pins to disrupt this guy. So you disrupt, you put a note, small delay, you put the values A and the values B into this operand, okay, and then you delay again, then you restore the interrupt. Okay. Okay, so today's lecture is a bit short. Okay, we have lecture number 3 for assembly language. I hope that you benefit from today's lecture. If you look into yesterday's yesterday night I posted this tutorial on the assembly language. I think they will be helpful. I actually, it's not intentional. I just saw that the codes are very similar. So please look into that tutorial. It will be able to help you for your labs. Okay. So I think that's all for this week. I share with you guys again the tutorials and the quizzes, the answers for the quizzes. I will discuss with Dr. Filbert to get the answers. Okay. So I think that's all for this week. See you guys again.